Hi, I am Jashvita. I am going to present a paper on evaluation in open source software, a case study. It was written by Michael and Quantum. Let's get started with authors and journal. Michael has H index of 42, and I did not find the other author H index. This paper was published in Proceedings of International Conference on Software Maintenance. This paper was cited 803 times. Research questions. Authors want to examine open source in detail. They wanted to see their evaluation is significant or different compared to the commercially developed systems. So their motivation was most published studies were system developed in-house, so they wanted to study development of open software, which is evaluation of Linux operating system. Open source code is freely available. The software can be tuned and adapted according to the developer personal requirements and highly collaborative like many corporate or individuals first start in build and then they later release another open source or with license which will allow freedom for a person to use system example like Mozilla project and geographically distributed and developers from any part of the world can make use of it and edit it. Open source versus traditional process. In traditional process, owner is ready to invite others into the project. Code base will be available to others and then developer starts. Anyone may contribute towards the development of the system, but owner will have power which contribution may or may not become part of the official release. On the other hand, open source development create a interesting system to who can work on it, often unpaid volunteers who can contribute to the project as a hobby. In return, they receive pre-recognition and self-satisfaction. These are the features of the open source. First one is scheduling. Particularly developers doesn't have scheduling because most of the people will be working as a full-time employees and in the free times only they will be working on the code and this project owner can release a system whenever he is satisfied. So they are large immune to time to market and code quality. We cannot insist the developers to develop uh, on standards because so many people have different standards and but many projects have official guidelines. Unstable code is common because developers are eager to submit their contribution to the project. Even this was addressed in the Linux and planned evaluation testing and preventive maintenance may suffer because large people will be handling it like in testing. Linux operating system originally written run on Intel 386 architecture and they are ported to numerous other platforms like PowerPC etc. Linux has been managed and maintained along two parallel paths. First one is development part and the other one is stable release. In the development release contain experimental and relatively untested codes and in stable release it consists of most of the updates and bug fixes related to previous stable release. Kernel number define which path it belongs to. If it is an odd number, it is a development kernel, and if it is an even number, it is a stable release. Methodology examined 96 kernel versions in total. Out of them, 34 were stable and 62 are unstable release. They measured stable kernels because the development kernels are released frequently and the stable kernels are less frequently released. The size full distribution was measured as a tar file with zip. Source files are only included, that means whose name end with .c, .h and other are ignored. They only used uncommitted lines of code because they found that total system uncommitted lines grows similar to the number of source source files. Difference between average and median file size is below because there were great variation in file size in some parts of the system. So using software files would be losing some part of story of Linux. They examined evaluation in system level and major subsystem level. They found that investigating major subsystem is better than system level because the growth rate was strong. In system level, they have examined new system growth using several metrics. First one shows the growth in size of compressed tar file, and second one shows the growth of number of lines of code. From this, we can clearly see that the growth is superlinear over time, and they also plot the growth against time ra- rather than version and number, but that did not make sense because both were parallel in real time. Then they plotted the median of .h and .c files, which you can see in these graphs, and they show fairly stable with slightly growth in C, which is you can see here. Growth of major subsystem, or after investing growth in system wide, they invested on growth of major subsystem. There are 10 major subsystem. First one is drivers, contain collection of devices from various hardwares, and Arch contain code specific to CPU, including code of library and memory management. Include system consists of .h files. Net main Net consists of main networking code. FS consists of support of various kinds of file system. Int consists of initialization code. IPC consists of code of inter-processing communication. Kernel consists of main kernel, which is architectural dependent. LIB consists of library code, which is also architectural dependent. And consists of memory management code, which is architectural independent. Here this shows the growth of the major systems. We can see that drivers are not only the largest, but it is uh, growing with almost 1 million. So here is the drivers which is growing, and here the drivers are growing steadily relatively to the system, but we can say that 60% of the subsystem are drivers. We cannot see other subsystem clearly because of this. See here we can only see the drivers, and the other subsystem are unclear. In this we can see relative size of the system versus total percentage, where arc include and fs is larger than remaining 5. The They continually grow linearly. Fs is more slower than the others, which you can see here. And this is the growth of the development release of the subsystem of the drivers. We can see the largest is .NET, which consists of growth of the which contain the growth of the networks. Generally, devices is used to translate a common and well understood request into task that is particularly hardware can execute efficiently than complicated. Now let's conclusion. Linux was very successful and open source large software development model. They examine growth of Linux in 6 years lifespan using different versions, and growth rate is surprising and large size, 2 million lines of code including current and development models, which is highly collaborative and geometrically distributed. They previously published research suggests that the growth of the large software system tend to slow down as the system become larger, and growth patterns of the subsystem to gain better understanding of how and why system seems to have been able to be successful. These are the conclusion, and this is the reference paper which I have presented. Thank you.